The first question that we wanted to kick off with, and we'll just kind of go down the line and have each of you answer, is kind of thinking about this intersection of space instrumentation and astronomy from space and the SETI and technosignature community. So feel free to speculate here, even if this isn't necessarily a main part of your day job. But what work do you do or missions do you work on that you think have a really significant technosignature connection that we might be able to kind of bring out and exploit among this community while we're thinking about how to find technosignatures in space? So I think, Mary, I'm going to force you to go first here.
All right. I will do my best. This is not a field that I work in, so this will be wild speculation, and please forgive me in advance. So I work in low frequencies, and I'll note that, our communication architecture, for humans has really moved from low frequencies in the early days of radio communications. HF was kind of the early over-the-horizon communication method because you have to bounce signals off the ionosphere, which is convenient to get them over the horizon for long-distance communications. And then, as we've gone on and we needed more bandwidth to fit more data into our communication channels, we've worked up the spectrum, to gigahertz frequencies, now even into optical communication. So, having the ability to sense very faint signals at low frequencies potentially gives us the opportunity to see another civilization work up that communication technology ladder, unless they've come up with something entirely different and from what we did. So these high sensitivity arrays, either on the lunar surface or free flying, have the potential to pick up these very faint signals. The Earth has a bubble of HF communications propagating out into space from the last 100 years. So that's in range of a number of nearby star systems. They're in range for us too. So that's my connection.
Yes, so I guess, sorry, again, I'm not an expert in this, but I guess potentially the lunar exploratory observatory, so I think personally, it would be an interesting opportunity for detecting technosignatures, such as the FASA array or others that I discussed with a large collecting area that would, again, this is again back to the low frequency regime in the application for cosmology. However, that I think why not look from there to begin with? And then I guess currently wherever there's sensitivity, even on Earth, like all the large ground-based telescope that's coming, I guess there could be interesting opportunities such as the Rubin Observatory, for example, that yeah, I guess that will get us started there to explore different wavelength range. I think that would be very interesting. Yeah.
I didn't really talk about it in my presentation, but a possible, I guess a possible thing in which I've dabbled, pulsar searches or searches for fast radio burst, particularly fast radio bursts, some fraction of them appear to be band limited, so they don't emit over all frequencies like pulsars do, but they emit over some restricted range of frequencies. Our planetary radars also tend to emit over, or transmit, only over a limited range of frequencies. We do planetary radar both for planetary science and for planetary defense. And so one possibility would be that we detect serendipitously as part of, say, a fast radio burst search, the planetary radar emissions from some other civilization. I think it would again turn out, even if we detect it, confirming it could then be the next challenge. But it's an interesting, do the radio astronomy because it'll lead to good scientific discoveries, and along the way we might also pick up some technosignatures.
I don't work in any large project related to SETI personally, so I do most of the work that I do is very lonely work that I do mostly by myself. In my institute, the Instituto de Astrofísica de Canarias, there's not a SETI group. But I am interested in what can we do with the existing data on exoplanets, particularly light curves. So I'm very interested in the possibilities because we keep getting more and more data, better and better data. I think SETI is a game of numbers. I think that's something Joe left very clear. And intelligence and technology is probably something very rare. So we need a very large pool of possible targets, I think, to have a chance of success. So that's why I'm interested in this. In particular, I'm interested in the technosignatures that could be left by artificial satellites. It's something that we are doing more and more. I think the geostationary satellites are very interesting, first of all, because it reveals an artificial, a conscious purpose. Nature doesn't put anything in, or at least there's no reason, there's no particular reason, there's no particular effect that will put rocks in geostationary orbit. So if you detect something in the geostationary orbit of an exoplanet, that will indicate clearly, at least Occam's razor would suggest that it's an artificial thing. So I'm interested in the longevity of a satellite belt, because what we do with our satellites when we are done with them is we push them a little farther out to what is called a graveyard orbit. So this graveyard orbit is going to gradually increase its population over the course of time. That's something that is happening with our civilization, and I think the same would happen with other similar civilizations, and it might get to a point where it could be detectable. And I love the idea that we are doing space archaeology by looking for the graveyards of other civilizations. Because what I've been working on is studying the longevity of these graveyards, and it could be probably much longer than millions of years. So we could potentially detect the graveyard orbit of civilization that maybe has been gone for millions of years. And I find that very... I don't know, evocative is the word? I don't know what's the word in English.
I would be interested in collaborating with natural scientists who want to identify and characterize whether there are some unique or exceptional sites or conditions on the moon or other celestial bodies that are uniquely or exceptionally valuable to this form of science, to SETI, and to determine how they could be protected and maybe take steps in that direction to ensure that those unique resources are used in a way that allows us to fulfill their scientific potential. I think most reasonable people might agree that if there are such sites or such places, especially say on the moon or on a nearby asteroid, then we owe it to ourselves, our species, our children, to ensure that they're not despoiled or degraded for some lesser purpose, or at least that if we do that we don't do it by accident, that we have deliberated the choice and made it intentionally and thoughtfully. So yeah.
All right. There are a lot of things in there that I would love to ask questions about, but as chair, it's my job to let you all ask those questions first. So with that, does anyone want to ask the brave first question? And I think there will probably be mics going around. Is that the setup here? Yes.
Oh, okay.
I got the first mic. Yeah, I'm Phil Mauskopf from ASU. I'm going to do two quick questions. One for Su-Ching, just an easy one, and a plug. So my question is, can SphereX detect Dyson spheres? And then the second question, which is for Alana, which is, how is the moon possibly like Antarctica?
Well, thanks, Phil. Actually, I thought about that when Sophia asked that question, but decided not to mention SphereX for this. I guess as you know, for people in the audience, SPHEREX is in the upcoming MEDEX mission that's going to be launched in early 2025. It will do an all-sky near-infrared sky survey with some spectral resolution between 0.75 to 5 micron. There will be 100. You can think of it as 102. It will generate 102 sky maps in the near infrared, which is going to be really exciting. So in doing that, there's a very interesting survey strategy which Phil himself also worked on. That we're going to cover the full sky. So I guess Phil, as you know, technically I think yes, it will be possible, but I guess. Because the visit of the way we design the survey, where we cover the full sky 4 times, it could be might be a little bit difficult for confirmation if we wanted to see anything, or if there's a fluke, we couldn't be possibly rule out the possibility. So that would be something that we need to think a little more carefully about. And obviously, so for SPHEREX, we'll actually have 2 deep fields due to the survey strategy. This will be our low Earth orbit, and we'll visit the deep fields every about 87 minutes. So one in the north, one in the south. So that could be an interesting idea for looking for transients and also, possible techno signatures. But again, because the sort of the cadence is a little bit, it's not a constant cadence for the visit, so we will have to work a little bit more creatively in looking for different transient events. But I think that's definitely something that we should look into. Yeah, thanks.
So in the study of global governance and space policy, or the governance of space activities, we often draw parallels with some form of terrestrial analog. So it might be Antarctica or the deep seabed, maybe even Earth orbit, and countless others. Those analogs are always instructive, but also always limited. They all present some strengths and weaknesses. We don't have any really one singular or terrestrial environment that really provides a very instructive analog. But nonetheless, we can learn a lot, of course, from the Antarctic Treaty and from what's unfolded in Antarctica. I think a lot of the discussion today centers on some big differences probably between Antarctica and the moon. One is that the international legal environment is different in the 2 settings. The Antarctic Treaty establishes a different context than does the Outer Space Treaty. A second big difference, and this I think remains to be seen, but is that a number of different actors today see actually much more economic potential, paradoxically, on the moon than they do in Antarctica. The poles, of course, are a dynamic environment on Earth, and they're melting and they're changing, and so no one knows exactly what the economic opportunities that might emerge there are. But we actually have today, I think, actors that have really grand ambitions for launching an in-space economy that's based on the active, pretty large-scale exploitation of lunar resources. And somewhat improbably, we actually don't have anything comparable on Earth's Antarctica.
Great.
Okay, so forgive me for not knowing the speakers' names yet, but I have three quick ones here. One for the person concerned about the lunar governance. You didn't mention it all. You mentioned Artemis and you mentioned COPUS, but you didn't mention the International Lunar Research Station, which China is developing on the same timescale with about 6 or 8 other nations now, in which they signed agreements on. That's going to be quite relevant in that time period. For the speaker on the question of interstellar objects, we've had Oumuamua and Borisov, but we predicted a lot more to come in the future years, and nothing's happened. You want to speculate on whether it's really rare or whether there's some reason that we haven't seen that? And then my final question on the technological on techno-signatures. Driving question in technology today is is about the future of artificial intelligence and robotics, which are going to, I think, would be be very relevant to the future of what's going to be out there in space in the future, and what kind of signals artificial intelligence and robotics are going to be sending out, or indicating what kind of techno-signatures they will have. I didn't hear any discussion of that.
Sure. No, I mean, you're absolutely right that any kind of conversation about developing international rules for activities on the moon has to include China and Russia. They will be very, very important shapers of this governance landscape. They will be among the early movers that establish a record of precedence, an early record of practice that is very likely to shape subsequent mission activities. So there's no question that any kind of discussion of rules has to include those parties. So far, there isn't anything comparable to the Artemis Accords that exists within the Sino-Russian context within the context of the Sino-Russian Lunar Research Station. But it's also plausible that something similar could develop, a similar statement of principles, for example, that all the parties or partners to that effort subscribe to, for instance. So I absolutely think it's very important to consider.
And let's see. I think, Daryl, I can see you on our little monitor here. I don't know if you have audio to answer that question, and if you were able to hear that previous question, I think directed to your work.
I mean, can you hear me now?
Yes.
Okay, maybe you can put me up there. Oh, there I am. Yes, I could hear the question, actually. So I agree that it's a little bit, I wouldn't say it's very strange, but it's a little bit strange that we haven't discovered another Oumuamua-like object. So the main thing is that LSST survey that's coming online, the predictions that we made for detecting future objects are based on the discovery capabilities of LSST, which is going to be 3 to 4 orders of magnitude more than Pan-STARRS. So next year, when we get the first light on LSST, and then the year after when we get the survey, that's when all of our predictions should start coming. So we're predicting that we should start detecting 1 to 2 to 3 objects per year once LSST starts. But I should also note that all of the predictions that we've made and published about what LSST will find is based on the discovery of Oumuamua with Pan-STARRS, which is the current survey in Hawaii that discovered the object. And from that discovery, by characterizing how sensitive the survey is, the number density, you can infer that there's what the spatial number density in the solar system of objects like Oumuamua is. So at first, we thought there was 0.2 Oumuamua-like interstellar objects per AU cubed, which is about 1 to 2 in the inner solar system at any given time. But because since Oumuamua was discovered, there have been no more discoveries like Oumuamua, that number actually gets revised to about 0.1. So I think it's more that the non-discoveries with Pan-STARRS since then just tells you what the number density is. And me and Dave Jewett wrote this annual review article there where we go through that argument very carefully. So I can send that to you or refer you to that. But that has been considered in our predictions for what LSST is going to find.
Yeah, and regarding the third question about the origin of the technology, I think I'll let Joe answer that question. But first, I wanted to make a clarification, perhaps, that when we talk about technosignatures here, we define technosignature as an observational evidence that there is technology. So we are focused on what is it that we can observe that will indicate an artificial origin. But it doesn't matter from that point of view what is the ultimate, who are the manufacturers of that technology. This search is agnostic to whether that was made by biological beings or by their machine descendants. There are ideas in the sense that most likely when we make contact with another civilization, we will be make contact with their machines, but that's pretty much irrelevant from the point of view of astronomy and searching for technosignatures, I will say.
full agreement. And the only thing I'd add is, in one of the existence proofs that I cited, actually all the existence proofs that I cited, they were machines that I was pointing at, robotic science missions. So I think that kind of echoes Hector's point that regardless of what we find, it's more likely to be silicon or metal or something like that than wetware.
Maybe I could just add something to that. I think it's a really good question. And I think we need to understand that, if there are robots with AI, that they will operate in different ways than we do. And they will operate in different environments than we do. In different places, they'll have the opportunity to operate in places that we cannot. So I think we should be thinking, when we're thinking about the detection of technosignatures, we do need to try and frame that in a sort of future-orientated way. And understand that, we use radio waves here because, we're inside a building, because we have to be inside a building, and radio waves are really good at going around corners and through doors and even windows and walls. But, these robots, they might be out there in the solar system, they might be using direct optical or laser communications or whatever. So I think we do need to be open for the prospect that those technosignatures could be a bit different from the ones that we're looking for at the moment.
Great, thanks very much. I'd like to invite some of our guests online. George Church, I think, is joining us from Harvard. George, please go ahead and ask your question.
I didn't really have a question. I was invited to, and I just said yes. Fascinating discussion.
I see. Okay. Well, in that case, why don't we move on to Ron Eakers?
Yes, Ron Eakers from Sydney, Australia, where the sun that you're seeing out the window is just rising. So interesting that we can see the same objects from both sides of the Earth, which we knew would happen. I'd also like to thank the organizers for being very inclusive with us online participants. And while too bad I can't get to meet you in person, the consolation is I have decreased my carbon footprint. So my question is to Ilana, and for background, I wanted to note two things. You talked about special sites, but there's also a special occurrence, namely that the lunar far side is the most radio quiet place in the universe. So that's not quite a site, but it's also something that needs protection. I have been involved in the past in attempts to get international protection for radio quietness on the far side of the moon. Organizations like IAU, ERSI have been doing this for decades. My question, however, is we have had relatively little influence, and the international body that can have most effect on this is the ITU, the International Telecommunication Union. But there are many players who are far more powerful than the scientific community. How can we influence the international situation in a situation like this?
Yes, a modest little question. Thank you. So first of all, of course, I spoke primarily about sites, but really it's more productive to think of conditions on the moon that are in need of protection. And I think part of the challenge now is at the stage that we're at is actually developing the right conceptual vocabulary for characterizing what it is exactly that should be protected and how for scientific opportunity. So we're still really at this very, very preliminary stage of kind of basic conceptual development and elaborating a lexicon. So I think the efforts to protect the lunar far side are very, very important. I think they have been ongoing for a long time. I think that probably the landscape within which they unfold has changed a lot in the sense that I think there's much more enthusiasm for astronomy on the moon now than there was 10 or 15 years ago, say. So there's more urgency perhaps to the problem, and there's greater loss to actually be characterized and understood. I mean, there's greater actual, practical, feasible scientific opportunity that could be lost if we don't take active measures to protect it. So the science itself now is more feasible. There's also so many other activities that could either undermine scientific opportunity or, harnessed to the ends of science, could actually be complementary with certain scientific missions, like various commercial missions. I mean, we just saw the image of a Starship, for example, that will a commercial development that certainly could help science along. And there are many similar examples. So it's a really different environment now, where I think the problem is more urgent, but also the opportunities are greater than they used to be. I think, in general, if we're honest with ourselves, if you think about the sum total of the professional space community, the people who work full-time in something space-related, there's a really large defense sector, there is a large constituency for human exploration and associated large engineering projects. And there's an enormous space applications industry and sector. And then space science has, relatively speaking, been weak and small and under-resourced. The ITU is a very important body to be active in, absolutely, but it primarily serves the interests of commercial space applications companies. So I think part of the big challenge for the scientific community is to engage in that outward-facing agenda that requires changing the public's and decision-makers' appreciation of what space is, raising or elevating the consideration that is granted to science relative to other priorities that can be pursued through space activities. I don't think the SETI community, as brilliant and inspiring as it is big enough to achieve that kind of impact on its own. So I think the most promising way forward is really to build the kind of broad interdisciplinary coalition that can advocate for scientific interests in space and governance measures that serve the interests of science across a wide different range of specializations and sectors. And that's the only kind of grouping that could be weighty enough and influential enough and have the kind of reach and maybe public impact to have more influence and to really present a counterweight to the, I think, very influential commercial interests and the long-established human exploration community, for example. So it's not that necessarily scientists need to see themselves as in opposition to those groups, but rather that they should define a partnership with those groups on terms that serve scientific interests, rather than defaulting into this position of being secondary and inferior players.
Could I just augment Elena's point? With due respect, Ron, the ITU actually has very strong language about the far side of the moon within its recommendations. I mean, it's extremely strong at low frequencies, but it is a question, as Elena, as you said in your talk, okay, so if a government can auction off parts of the radio spectrum on the Earth's surface for billions of dollars, what's our answer? And it unfortunately, it requires getting involved in fora that, you know, typically we scientists and engineers are frankly, less comfortable in, because it's not the hard numbers. It's, you know, the kind of more qualitative arguments that perhaps social scientists, political scientists are more comfortable making.
Okay. Should we move on to another question? I think we have a question over here.
Yes. Is it on? Oh, perfect. Well, Alana, sorry for making you talk so much, but I do happen to be a part of that establishment that you were just discussing about that has a lot of influence in space and space policy. So my background, I'm in flight ops. I work a lot on Artemis and all the moon missions, as well as being heavily involved in the commercial space industry. And your discussion specifically was incredibly interesting, just because that's something that up to this point, I, myself, and many of my other coworkers have never really considered, because at the end of the day, what we're focused on is getting the mission done, or getting the the job done as cheaply as possible. So I guess I'm curious, in your view, what sort of the ideal trade-off would be between those commercial space and space exploration interests and space research interests as well.
Yes, another modest little question. So I think, again, we're at a really preliminary stage. I think the first step for the research community is to identify what's at stake to be lost and what are the sites and conditions that are genuinely deserving of robust protection. It can't be everything, right? It has to be a small number of things, because if the protections are too restrictive on other activities, no one will accept them. They won't be legitimate. They'll have no chance of ever having any kind of real impact. So I think the first step is really defining what the priorities for protection are, and I think that is an ongoing process. SESIs are not defined once in time because they're dynamic. They evolve with technology. They evolve the way scientific opportunity does with the new possibilities created by new instruments and so on and so forth. So that's, I think, a crucial first step. And then I think from there, we feel our way towards some guiding principles, some fundamental principles that I think any reasonable person can recognize as intellectually compelling, as ethically and morally compelling or persuasive. An example might be that maybe we reach agreement on the idea that if there are certain sites at which you could do some high impact science, some science that would revolutionize potentially how we think about ourselves or our planet or our universe, and you can only do that science at that one place, or that place is uniquely suited to that kind of science. Well, maybe we say that that site should definitely be reserved to those types of missions and not to other types of missions that essentially pursue objectives that could be pursued elsewhere. I think a likely example of attention is with commercial prospecting or resource exploitation missions, especially those targeting water deposits on the moon, especially those in the cold traps. There's great commercial interest in harvesting water on the moon. But the end goal of that activity might be developing propellant, or it might be sustaining some form of human presence, developing a human habitat, any number of different things. But those are all fundamentally substitutable and fungible. You can make propellant in other ways. You can supply water in other ways. You can even bring it from Earth. So we should probably determine what are kind of fungible uses of a particular high-value site, what are substitutable ones, and what are really unique ones, and prioritize the unique science when it's in conflict with those other kinds of missions. Does that get it, like your question? Yeah. Okay.
So Ron Turner, I'm sorry, I see, we seem to have lost you. You've been very patient. If you're still there, then feel free to come back on and ask your question. I know you're joining us from the UK. Otherwise,
Shall I go?
You go first, and then if Ron comes back on, we'll get a question from him. But
Okay.
we only have a couple minutes left. I don't want to eat into lunch, so short questions and short answers if possible.
Okay, I'll be quick. So this might seem a bit pessimistic, but I think we're all going to die very soon. And I'm not sure for how long the residue of our civilization would be detectable. And I hear things about us potentially destroying the lunar far side and being detectable through our litter in the satellite graveyard. It makes me more pessimistic. So my question to the panel, to whoever wants to take it, is can you provide any cause for a more optimistic view?
Can I take this one as chair? This is something I think about a lot. And the answer that I've landed on, at least for now, is that anything that we detect kind of by the numbers, by this sort of same large numbers problem we keep running into, like any extraterrestrial agent we detect will likely be a lot older than our species on Earth. And so in the past, a lot of SETI theories have kind of used that and said, okay, well, what if we take the sorts of things we do right now like extracting energy and scale it up to massive scales. Like they'll still want to extract energy and trash their environment and like not really care and hop from star to star or these sorts of ideas. And now I think there's a bit more of an understanding in the community that like if you have, say, large scale energy collection or production on the surface of a planet, you're going to create byproducts. You're going to heat it up. There are impacts on the environment once the scale gets large enough. So if we do run into something that's been around for a very long time, it's going to have had to figure out how to be sustainable. And so I've had some of these conversations at workshops thinking about what sustainable technosignatures might be like. And to throw one out there that Jill Tarter likes to use, if you try to characterize an exoplanet system and you see a planet in the habitable zone with some particular temperature or atmospheric composition, it doesn't even have to be in the habitable zone. You see a planet with some characteristics, and then you look at its neighbor, and its neighbor also seems to have very similar characteristics in its atmosphere and temperature. That could be telling you something about some species that has a particular preference for its environment that's maintaining that environment and sustaining it on multiple planetary bodies at a time. So I think it's an area that needs more work, but there are examples of thinking about how sustainability kind of has to be built in to these really long-term extraterrestrial intelligences or civilizations that we say we're looking for. So we should really put more of a focus on it.
Another perspective might be, that could be an example of human hubris. The Permian extinction, if I've got the geological stuff correct, wiped out something like 90% of the life on this planet. Okay, you could wipe out humans tomorrow, and that probably wouldn't affect life on the planet. The real race is, and the Permian extinction was it was 200 million years ago or something. I mean, the real race is, even if you wipe out humans tomorrow, the sun is getting hotter. The oceans are going to boil off in 1 billion years. And so you can already hear the astronomer talking, right? There's a 1 billion year race here of, nobody's going to stop the sun from getting hotter. So on what time scale do you get to either sustainable technosignatures or the next intelligent species on the planet?
Can I add something else to that? That's a really interesting argument. I think there's even less than 1 billion years, because even before that, this gradual heating will have catastrophic consequences on the life on this planet. It's probably not going to be habitable for more than 600-700 million years or so. And one thing that bugs me is there's plenty of time on this time frame for a civilization or a species like ours to develop, to do its thing, to live, to die, and then other intelligent species come up. And yet we seem to be the first on this planet, right? There's potentially time for 40 or 50 intelligent species in this cycle of coming up and coming to an end. So it bothers me that we seem to be the first one. And I don't know what the answer to that is, but one possible answer is that when we become extinct, we sort of wipe out the biosphere of this planet. I want to think that that is not the answer to that question, but it's something to bear in mind. But you asked for a more optimistic note, so I'm going to change perspective. I'm going to change perspective a little bit. When we are doing SETI, we are looking out at the huge universe and trying to find another intelligent civilization that is still out there. The numbers only work if there is a chance that at least some civilizations can live for a very long time, tens or even hundreds of millions of years. Otherwise, SETI is hopeless. So if we can ever detect a signal, even if we cannot, decode this signal, but if we get a signal, it will mean unequivocally that this is possible, that it is possible for civilization with technology to live for a potentially long time. And this is a very valuable lesson, because we don't know if that is possible. So there's basically two possibilities. If we make contact with another civilization, it has to be, like Sophia said, very old for technological reasons, or we find the remnants of an extinct civilization. And that's what archaeologists do, right? When they learn about ancient civilizations, they dig up their graveyards and they try to figure out how these people lived. And that's, it's part of the cycle of life, that civilizations, appear and disappear. I don't know if that's really that sad. Maybe it's something we have to accept. But there's a chance, and I think that's the beauty of SETI. It's a search for hope. Because if we can detect an old civilization, we will learn so much from it. It will change completely the fate of humanity.
Thank you very much, Hector. Mike or Sophia, do you want to say a final word before we break for lunch?
Maybe I should say something. But yeah, no, I would like to thank all the speakers again. All the fantastic questions we've had, and hopefully this discussion can continue through the day and through the next couple of days that we're all together. I think Evan's question is really an interesting one. I think every generation sort of feels that maybe things are going in the wrong direction, and maybe they are going in the wrong direction, but I think we have to be optimistic that, we will sort of prevail, and we will start moving throughout the solar system, and we will detect other civilizations, and the future is going to be fantastic, and we will learn so much more about this miraculous universe that we live in. So thank you, enjoy your lunch, and we'll see you in the afternoon.